Hello everyone, good evening. From what I can tell today in the class, most of you know how to sketch a Bode plot using the frequency point in a transfer function. That's a good news. The only thing that I see people are struggling is to find out the constant, and that's the whole purpose of this point for this video clip. We're going to talk about how to determine the constant value of the transfer of a transfer function. So the purpose of this video is to show you how to the plot will be shifted up or down, because the constant will determine the the shift up or down based on a different constant value of a transfer function. The trick here is that the constant will be determined based on the first segment of the linear interpolation of the sketch. So if you had the first sketch which is trending downward for that 20 dB per decade, that is the segment that we will be based upon for the entire searching for the constant for the transfer function. So as you can see from this first page, that the constant of the first transfer function will be always based upon the first segment of the curve, and it will be always based on this equation that can be found from page 593. I'm just going to use this equation for you to find out the constant value. As you can see, that plus minus here, it really depends upon the first segment, whether or not it is going to the positive slope or negative slope. So you have to carefully apply this, because that will determine the y value, which is a transfer function. So this is a 20 logarithm of 10 with k constant 0. So this is a constant, either you will be given or you will find it out, and then divided by j omega to the power n. So the n here is actually determine the slope. So you have minus 20 dB, then the n here is going to be 1. And then if you have 40 dB, then that's going to be 2 apparently. And what we're talking about here is the magnitude, because eventually we're going to need the positive value here to force them is equal to 0. And you know that to get that into 0, whatever logarithm 10 here is going to be, has to be, this whole term has to be positive 1. So what I'm going to talk about next page, which is one of the questions that we talk about suggested today, is 12.13. So I have already prepared the whole thing here, that as what we repeated in the class, except the constant explanation in detail is that you have the 20 dB, and whatever here, it has to be with the format of plus 1s here. So I reorganize this a little bit and write this function as 20 with the s divided by 10 plus 1, divided the whole thing as times s plus 1 times s divided by 100 plus 1. So bear in mind that you actually have the term here s only, whether or not it's in on the denominators or denominators is always tricky. So we want to carefully pick this number as we go through to plug in the number to search for the point of the constant value here, which is shown as the x. So I'm indicating x here, and I'm going to talk about this here, because we have to carefully pick the s. So usually what I would do, s is equal to j omega, and I pick 1. And the reason I pick 1 is for easy computation. So you can see that to find out the j omega magnitude, you put 1. 1 to the power 1 is actually 1. So the only thing here is you have to find out what will be the value here. So you have k0, which is indicate here 20. So before you actually take this for granted, you have to make sure that whatever the rest of the function has to be plus 1, plus 1, and plus 1. If that is more than 1, you have to organize it in this format before you actually take that constant, because that can be very, very different. So that k, the 20 of the constant, has to be in this format before you take that value, and which I did, 20 divided 1 to the power 1. So you have j omega equal to 1. Again, this is what I pick it arbitrarily because of the s value, right? So we want to get closer to the left hand side, so we pick 1 to the power 1 in this case, because you have 20 dB, so you have the power 1, and then again the constant is 20. So when you plug it into your calculator, minus 20 logarithm 10 of 20 is actually equal to minus 26 dB. So that's the y-axis, as I have shown here, is at minus 20 dB with a the at least you have to do the mark here to show that you found the point. This is actually an indications of how you relate this constant with this function, that you force them this value into this. So you might ask, what about if this value, say, is not 20 anymore? Let's say it is 500 or whatever the number will be. Well, the same principle apply. So in this show, I say if k0 equal to 500, you're going to substitute this 500 here. And again, for simplicity, because there's the denominator value, I want to make it as simple as possible. So I always pick 1. 1 to the power 1. So you have 500 divided by 1 to the power 1, and you plug in this to your calculator. You have minus 20 multiplied by log 10 500, and that gives you minus 53.98, which approximately to be minus 54 dB. You have this y value as minus 54 dB x. So structure-wise, the entire curve that you have here is going to be shifting up or down depending on the constant here. And you know, if you do this correct transfer function and be able to plot it correctly, you almost get 90% of the answer correct for the entire questions. So I'm going to talk the other two questions from now on, which is 12.29 and 12.34. 12.29, same thing. As you can see here, is that usually the question will be given to you. Again, it has to be based upon the first segment. So you have I explicitly highlight this black color as the first segment, and the dot 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 here is actually indicate the same slope here. And the additional information given in this plot sketch is that you have phi over 0 dB, and apparently we don't have the frequency breakpoint because it's all based upon how you find out the segment of each of individual linear point. And that's what I have here is S, because you start with the negative slope first, so you have S, and then to the point of minus 1 you have S divided by 0.1 plus 1, and then you start to trend a little bit up again by having a minus 20 dB per decade. So you have that 0, which is S divided by 1 plus 1, which is S plus 1, because you only have 1 here. And then eventually you go out another deeper slope here, minus 20, which apparently you know that this is going to be a pole, which is S divided by 50 plus 1. So all this fall nicely, except we need a constant. So again, the same principle apply, because we are having this as a trending downward. So you're going to have to pick minus instead of plus here with the 20 logarithm base 10, and then magnitude of the constant value, which we're going to determine next. And then the j omega n here is that, since this is as nicely given to you, so that phi will give you 0, so you put phi to the power 1, that force them into 0, and then to find out the k0. And you know right away, right, the whole term here, the logarithm 10, in order to make the whole thing entirely to be 0, it has to be 1. And what would cause that 1 would be you have k0 divided by phi to the power 1. So the k0, the constant, has to be phi, because phi divided by phi to the power 1 would be 1, which will give you 0. So here we go. The k0, it will be the phi. So the next question, which is similar as the last question, and it's already given you the order frequency breakpoint, and I'm sure all of you know how to actually do the transfer function except finding the constant. So when you look at this, I put the x here because it reflects the first slope. Again, the constant is about the first slope here, and it's already given to you by saying that you have 12. When the frequency is 12, that gives you 0 dB. So again, based on that equation, it has to be minus, because it's actually sloping with a negative slope. So you have minus 20 log 10 with the magnitude of k0, which is a constant we're going to find out, divided by j omega to the power n equal to 0. Now this is already given to you 12, so you're going to substitute 12 to the power 1, and you have to ask yourself, what caused the whole thing equal to 1? And because the 1 logarithm here is going to make that 0, so in this case it is pretty straightforward. You have k0, which is 12 here, and k0 is equal to 12. So that hopefully will explain, make it clear on how we're going to find the constant from based on the Bode plot or how we're going to use the constant from a transfer function to scatter a plot, because the constant will determine the position of the entire sketch. So I hope that the example that I talk about here, particularly the first question, will give you the intuition about how this will change shape up or down based on different constant. Hope this helps.